Hi, I'm RC Jim, and I'm getting ready to go flying tomorrow morning. And nowadays I'm all into electric planes, and so that means I need to charge up some batteries. So first thing I have to do is decide, what am I going to fly? And I think I might go for, say, the Super Air, that guy with a yellow stripe down the side. And how about the MX2 over here? Now, what that means is I need to have the right batteries charged for those two planes. And so hence this little video here is going to be all about the batteries and some really big surprises that you're going to have in terms of what they can actually deliver. This involves having done a bunch of testing and looking at it very carefully, but I want to present it in a way to where it really helps you to understand what these batteries do, what they're all about, what the terms mean, what you need to be careful with, and some implications in terms of how you fly. So let's get right into it. As I've selected which planes I'm going to fly, I know which batteries I need. So the Super Air, I run 4S batteries in that. We'll talk about what that 4S means in just a moment. And here I've got a couple in a case. It is a good idea to protect your batteries in a case. Now this is fire resistance, at least. They'd like to say that it's, safe from explosion and fire and everything, but it's going to be some help, if something goes wrong. It also has a little bit of protection in it. It's got a little bit of padding and whatever else, plus I add some other padding along the way. And the reason for the padding is that these things are in a soft package. They save weight by not putting it into a hard case. If you had a hard plastic case around this whole thing, that's going to add significantly to the weight. So with the airplanes, we use these soft packaged LiPo batteries. We're going to need to charge it, but before we get into the charging, and we're going to be looking at 3 different brands of chargers and why you might pick one versus another. But before we get into all of that, let's think just a little bit about these batteries and what you got. Now, I might say first off, I say batteries, battery. It can be pronounced in a variety of different ways, but here in Australia we like to be a little bit lazy, and so typically it's batteries. So you got a manufacturer, and when you get away from, even the main brands, there's a whole bunch of them, but outside of the main brands, there's just zillions of different brands of LiPo batteries. And you go onto eBay or, AliExpress or, whatever you're buying your stuff from, or even the hobby shop, you will find that there's a lot of different brands, and some brands seem to be better than others, and we'll be showing you later in the video some results of our testing with different brands of batteries. But with this LiPo battery, it's a LiPo for short, is what we refer to this, lithium polymer. And lithium polymer just means that as in each cell of the battery, you've got sandwich layers of differing metals that have ions that go from one to the other in order to produce the current. In a car battery like that, you got lead plates sitting in acid, and the electric current is going through the acid from one plate to the other plate, and multiple plates along the way. You don't want to have a bunch of acid in your airplane. It's hazardous enough as it is. So they've got a polymer, kind of a plastic type stuff, that has a chemical impregnated in it, and that's where the current can flow through that, and it can be handled much easier, and you don't have to worry about liquid spilling and all that kind of thing. The lithium bit is what metal that they're using, and lithium is something that is incredibly powerful in terms of how much energy it can store. But it also means it's rather dangerous. And so you hear about people's telephones catching on fire in their back pocket or in the airplane or whatever, in the airliner that they're flying in, whatever it might be. So they can be dangerous. So you have to be really careful with regard to them. So it's a LiPo battery. Then the next thing on here is talking about the capacity of the battery. This is 5,200 milliamp hours. So amps, that's current. So the flow of electricity going through there. Hour is the amount of time that it can go. And so when you're measuring amp hours, and milli is just simply saying 1,000th of an amp. So 5,200 1,000ths of an amp hour is saying 5.2 amp hours. But anyway, amp hour, it's talking about how much electricity can flow over a period of time with regard to the capacity of the battery. So with 5.2 amp hours, if you're drawing at 5.2 amps, it should last for 1 hour, if that is indeed the capacity. And you will find that it won't actually quite do that. Okay, so 5,200 milliamp hours is the capacity of the battery. ADC, that has to do with like an instantaneous jolt as to what the battery can deliver. Now, unfortunately, these things are rather inaccurate because there's not any set standard for how to measure that. You know, do you just simply plug an amp meter into both things, short the thing out, and see what you get? Or do you have some sort of realistic load on there? Or is it what you can do without the thing blowing up? You know, it's just not known what the standard is. But what it's supposed to mean is you take this 80 times the amp hours, so dividing that by 1,000, so 5.2. So you take 5.2 times 80, and that should be the number of amps that this thing can deliver. Now, we're talking about what, 400 amps? You know, a little more than 400, you know, 400 and a bit. I wouldn't want to be around if this battery is delivering 400 amps. You know, it's just outright crazy. But basically, the bigger the number over here is supposed to be, the better it is. And I think the main thing you'd be looking at is for one given manufacturer, if you're wanting to have a battery that has higher capacity and all of that, then you go for one that has a higher number on it. But comparing one manufacturer for another one, it might not be, you know, anything that you can compare. It might be apples and oranges. Okay, next is a voltage, and they might also tell you a S number down here. So this is 14.8 volts, 4S. 4S tells us that it's got 4 cells. So you got 4 different cells. The S says that they're connected in series. So as we look at our little chart here, okay, the typical thing that we're going to have is just simply all of the cells connected in series. And what that means is those voltages all get added together to get the total voltage, and the current through all of the batteries is all the same. It's just one set of current that's going through there, through the whole system. And so that's your normal setup as far as 3S. And they probably don't even mention the P. They just simply say the number of cells, and the S tells us that they're all wired up in series. When you add on the P's, the S part is telling you what the total voltage is, and the P is telling you how many parallel lines there are. So 3S2P has got 2 lines of 3 cells. 3S3P is what's shown here as 3 lines of cells, and when it says NP, it's saying, well, you just add on however many, and that's going to be the number in front of the P, you know. So the S is always going to determine the voltage, and the P's are added to increase those amp hours. So as you think about amp hours, since the current is the same through all of these, then the capacity is going to be just simply the total of the whole thing. If you had 2 batteries like that you put together, then the total voltage is going to be the same, but you're going to add together the amp hours, because you got half of the current that goes through this set, and you got half of the current that's going through that set to add to the total. So you get double the ability to deliver amps. Here, if you got 3 rows of them, you've got triple the ability to do the amps. And so if we were comparing this with individual batteries that are all wired up in this particular way, you'd have triple the milliamp hour capacity doing it in this particular way. So the P's are added in order to add capacity, and the S's are there to deliver the voltage. Okay, so that's your S thing. The 14.8 volts, that's talking about nominal voltage. Now, if you look at a graph of what ought to be true with regard to a battery, and I don't know that this is, I got this off the internet, but I don't know that it's necessarily from test data. It might be more illustrative. It seems to be a little bit different to my test data that I've developed. But anyway, what happens is you're discharging a battery, say this is the flight of your airplane. It starts up at a high voltage, and ideally 4.2 volts, and then gradually it's going to decline and come down to some point of voltage where the thing just totally drops off. As you look at this middle voltage, that's 3.7 volts. And so that's why they give you this rating on the battery that says 14.8 volts. That's based on the 3.7 volts per cell. And when I say the voltage here, that's for each one of these cells. Okay, so 3.7 times 3 for a 3S battery. This is a 4S battery, so it'd be 4 of them. Okay, so that's a 3.7 volts. But the maximum voltage, when it's fully charged, and if the temperature is high enough, is going to be 4.2 volts. When you go to use it, that's going to drop off in a hurry. In fact, even before you use it, it'll already have dropped off a bit. It'll probably start out at 4.1 something up there, and then very quickly come down. And then, of course, it'll gradually reduce through the flight. It is affected by temperature. So this graph here is showing you the blue line is saying what happens if the temperature is 25 degrees Celsius. If it's freezing, the red line going there, and the green line if it's minus 10 degrees Celsius. You might wonder why the dip and then coming up. Well, in actual fact, these are talking about ambient temperatures here. And so when you actually start drawing on the battery, and this, one would assume they're talking about drawing a current of 3C. So in this particular case, as we're talking about 1C being 5.2 milliamp, 5.2 amp hours. So 5.2 amps would be 1C, and so 3C is going to be 15.6 amps, okay? So 15.6 amps ought to last that length of time for that battery. And of course this chart is talking about, per cell. So for each cell that this is what would happen. Anyway, when you first start drawing the current, the initial temperature is just whatever this outside temperature is, the ambient temperature on the battery. But very quickly it warms up. As the current's flowing through it, the battery is warming up, and as it warms up, it brings it back up, and you get a better result than if it was to stay cold the whole time. Okay, so that's why we have the 3.7 volt thing. Then we got the 4.2 volts that we're going to be charging to down here. I might mention as well that with regard to storage, you want to store the battery between the 3.8 and 3.9 volts. That's the optimum level to keep it stored at. So if you run the thing right down, you want to bring it back up with a storage charger to get it up between 3.8 and 3.9 volts. Okay, looking a little bit more at the battery, you see you've got two sets of leads coming out of it here. You've got a great big heavy one, and you got this lightweight one. The great big heavy one is to deliver power to the electronic speed control, the ESC, that's going to give power to the motor. So that's your main power that's being provided there. And this little thing here is called a balance connector. Now, for what's happening with a balance connector, consider the battery that we've got here. And we've got a number of cells. In this particular case, it's 4 cells that are connected up. They're all connected up in series, so one end is the negative end of the whole thing. Then you've got the positive of this cell connected to the negative of that one, positive to negative, positive to negative, positive at the end, and overall, that's your overall thing. So the overall voltage coming out with the big heavy wires, that's that connector right there, okay? But you got this little connector, and what the little connector is connecting between each of these junctions between those cells of the battery. Now what that allows is when you're charging the battery, or discharging it with the charger, it keeps track of what the voltage is on each of those cells. And while it be providing the main current going through this whole thing, and I guess current going that way, positive and negative, and ions going that way, whatever the case might be. But anyway, as you have this main current going through the charge of the whole thing, it'll add little bits to these spots here to cells that are a little bit low. And it will be monitoring what the voltage is between each of these. And if one of them is lagging behind, it'll add in a little bit extra for that one, you know. And if, you know, something else is getting too much, it'll back off a little bit on that particular one. So I'm not exactly sure how all of the logic works, but essentially it's monitoring the voltage of each cell, and it's adjusting the amount of charge that's going into each one to make them all even. Now what that is doing is it's helping to make it safer by not having one charge get one cell hog all of the charge and take all of the power to itself and get way overcharged, and another one be undercharged. And potentially, if you have one that's way overcharged, it could be dangerous. I mean, it could blow up, and all kinds of things could happen. So it's very important that you always use a balanced charger, and this balanced connector on there is what does that. The balanced connector can also be handy for just having a look at what your battery is doing. All of us who fly electric planes, we will be using a little capacity meter such as this. With a capacity meter, what you do is you plug this balance connector into the end of it there, and it then tells you the capacity of the battery, just where we're at in terms of what voltage. So got 15.41 volts overall, and that would be measuring from one end to the other end. So keep in mind the balance connector includes the total voltage from one end to the other. So that's what this is, 15.41. Tells me we're right around 50%. But then I can push on the button and it'll go through the individual cells to tell me what each of those cells are. So the first cell is 3.858. Next one, 3.853. Next one, 3.854. Next one, 3.854. And then back to the first one again. So the balance connector can be used for that. Sometimes in the telemetry on the plane, there'll be a sample sort of wire that goes to the receiver that plugs into this red wire here, and that will be something that can measure the voltage of the actual battery, send it back to your transmitter so you know what's going on that way. Now, when I mentioned the storage capacity for this battery being at 3.8 to 3.9 volts, that has to do with long-term storage. Now, you can go probably about 2 days, 48 hours is typically what they'll say to have a fully charged battery, or charge a battery that's been depleted, down a fair bit. It can be okay for a couple of days. But anything beyond a couple of days, you need to make sure you've got it at the storage level. And certainly if you got the thing drawn way, way down, I wouldn't wait around to bring it up to something normal. But the main thing is like, say I'm getting ready to fly tomorrow, and I'm going to have the batteries all charged tonight. What happens if, for some reason, I don't fly tomorrow? Well, they'll be fine to use on Tuesday. And right now it's Sunday night. So I could wait a couple of days. So let's have a look at what we do as far as getting going with a charger. We've got our batteries, we've got our various connectors, and with any charger they're going to have a certain type of connection, and so you're going to need some adapters to take you from whatever you've got on the actual battery to whatever it is going to be on the charger. So with the SkyRC charger, it does XT60s as far as putting them in. And so we plug these things in there. Now, in this particular case, these you've got one place for the XT60 to go, and you got another place for the balance connector to go. Both of them are going to have the negative to the right, so negative on that side for the XT60, negative on this side for this. And sometimes you have to fish around a little bit to find the spot where it plugs in. And on this particular charger, it is possible to force that thing in to the wrong place. Fortunately, the charger has got a lot of protections in it from, things being incorrect. So I haven't managed to blow it up yet, but I have had it tell me that the polarity is reversed or whatever, and it's just due to not having hit the right spot. Okay, so anyway, we can get them plugged in, and if we are charging a bunch of batteries that are all going to be fully charged, and they all are going to take the same current, then we could put them all in together and tell it to get going with what we've got overall. But in this particular case, we're going to have some big ones and we're going to have some little ones. And so, as I plug in the big ones, I'll start with those to give them a head start. And negative, this way, as if you're facing it, negative being to the right. And the balance port, again, black is negative, black is on the right, so we plug that in there. So now we've got two identical ones in there. What I'll do is, A is blinking, so that means that's the port that I'm on. I press in on the wheel, and I have a look. Immediately it's figured out that I've got a 4S battery. It shows me the voltage on each cell for 3.85, so that's precisely what I would love to have. Okay, so I press it in again, and it asks me what I want to do. And it's got storage on there. It's a LiPo battery, 4S, but it's got storage because that was the last thing that I did with it. So I pick that, and I use the wheel, scrolling with the wheel, rolling the thing one way or the other to get to balance charge. Now, balance charge is where it's doing what we're saying here, where it's making sure that each cell is charged at the same voltage, and they're all kept very, very similar. Just ordinary charge would be where it's just simply going to throw the power through the big one, and it's not going to worry at all about what happens in individual cells. For a LiPo battery, that is not what you want to do. So we press in to select balance charge. It then asks me what the charge current is, and the last battery I did was 2.2, and it doesn't know that these are 5.2, so I press in there. And I come up to 5.2, being the amperage that can be used for a 5200 milliamp hour battery. Okay, I can then pick start, and it asks me, do I want to do this to all channels? Well, at the moment, I just got two identical batteries there, so yes, I don't want to do that twice if I can do it once. And so immediately I get started here. This is telling me a variety of things about what's happening. Tells me the voltage that the batteries are at right at the moment, and that's not what they would be after you unplug it. It's the actual voltage as they're being charged. Tells me what amperage it's being charged at, and I said do it up to 5.2 amps, and it's charging at 5.2 amps. It's got the individual cell voltages, and you recall it started at 3.85, so immediately it's jumped up to 3.91 in order to develop that sort of current going through it. Down here it's got a milliamp hour figure, and that's gradually climbing up. That's the amount of energy that's being put into the battery. And since this is a 5200 milliamp hour battery, and it was, around about 50% charged, 2600 would be halfway, and you'd expect it might need a little bit more than that due to inefficiencies and stuff like that. So got a long ways to go to get from the 93 right now to 2600. 81.9 watts, that's telling me how many watts are going into it. And you note that this is a 200 watt charger when it's plugged into mains power. It could do up to 400 watts when it's plugged into DC, but right now we're just plugged into mains power, and so 200 watts is the limit. And so right now, if we got two of them going at 81.7, that we're talking about 164 watts out of the 200 that's being taken just for two batteries. So obviously if I add on another two, it's not going to be able to keep up with that. To check and see what's going on with the next battery, I just click this port button, and that brings me to the B ports. That's A, B, C, and D. So on the B port, it's again, 5.21 amps, just a slight bit over what I told it to have as a maximum, and it's plugging along 188 milliamp hours so far, and it's doing it at 81.4 watts. Okay, now that that's going, I'll get ready with these next ones, and with these ones, it's already got an XT60 on it, so it'll plug straight into there. So that's handy. It means that batteries that have that, and that's a very common sort of size, will be all set. Can be a little bit of a gymnastic thing getting some of these things plugged in there, and especially given that I want to make sure that I get it where it actually belongs. So I wiggle it around until I feel the area where it wants to go in, and I push it in there. And I might mention with this big adapter over here, if I have that in here, then I have a problem getting the balance connector in next to it if it's got one like this one over here. One of those little short ones like that isn't so much a problem, but one of these big ones, if it got that big thing next to it, that's a problem. So having an adapter that has a wire leading up to that gives that sort of freedom to be able to get past that sort of thing. Okay, so that's that one, and these next two we'll have to start individually because we can't tell it and do it the same for everything. If we wanted to charge everything at a lower rate of amps, we could, and that'd be a distinct possibility. Again, negative to the right, so going that way, and with our balance connector, get the little tabs on top, so we got the negative going to the positive red one going to the left, negative going to the right. Put it on the right hand side of the area. That's ready to go. So now we go over to C. We press in. We want a balanced charge. It's 4S. We don't want 5.2 amps. That's what we had on the others. And these are 2.2, 2200 milliamp hours. So we'll say start. And no, I don't want to do it on all of the channels, so where it's colored in, we do that. Now, you note that there was a change in the tone as that happened. This thing kicked in, and as it kicked in, it's adjusted what it's decided to do with the other ones. We'll check on that in a minute. Right now, we'll go to the D and get that one going. And so we come down here. And again, we reduce this down to 2.2, and had I put these in the other way, I wouldn't have had to do anything. Okay, it's a balanced charge. We hit start. No, we don't do the same on everything. And now I can hit port again, and it'll give me a summary of what's happening. So we have a look, and we verify, yes, they're all doing a balanced charge. And look what's happened. Well, it's got the 2.19 and 2.2 amps for these smaller ones, what we specified. It's now reduced the amount of amps going into these big ones to something just over 4 amps because it's got to stay within this 200 watt limit. So it's going to be keeping an eye on that and making sure it's going to operate at a level that it can handle. If you have a whopping big, 6S or 8S battery, something like that, then you find it's going to be way, way down. It's keeping in mind with this watts, the watts isn't just the amps, it's the amps times the voltage. So with the bigger batteries with more cells in them, the voltage is going to be higher, and so even with the same number of amps, if we say had a 6-cell battery in there, you got 50% higher voltage. That's going to have an impact on the amount of current that it can handle. Now let's have just one more look at what you've got in here of this information that's going on. We mentioned about the volts per cell and these other things, but with this wheel here, you can also scroll it off to the right, and that's showing you the resistance in each of those cells. Now, with that, you can see we got 4 milliohms, 4 milliohms, 4 milliohms, 6 milliohms. It tells you whether things are, easy for the current to flow through or whether there's a lot of resistance to that. Lower values are good, and the lower values are what you want. But as we cycle through our batteries and we have a look at that, we see first off between these first two, the first one is a little bit better than the second one, but not much different. I think that one had, very similar. Okay, we cycle to the next one, and we scroll across to get to the ohms, and now all of a sudden it's higher, 6 and 8, and then to the last one, scroll across, 6 and 7. Now none of those are a particular problem, but I've got some little 3S batteries that's way up around 25. Now they still work, but the higher resistance is going to mean that they're going to be less efficient and more power is going to be lost to heat than what is going to be available for running the motor. So that's just something to keep in mind. And the main thing to be looking at is if there's a whopping big difference on one of the cells compared to the others. So we'll let that get going. I'll get the planes in the car, and then we'll come back and we will show you the other chargers and how they work. And then we'll talk a little bit more about our test results, because they are going to be really surprising in terms of what you can actually get out of one of these batteries. And I might say a little bit disappointing. Well, thank you for watching. We're going to take a bit of a break at the moment. We'll have 2 more brief videos to follow, getting into more details. One of the videos will be looking at the SkyRC charger versus the Spectrum and versus a LiPo. Very different price points for each of them. 2 of them, you can probably guess which, are pretty good quality. One, I think, is really the way to go. So we'll get into that in one of these next 2 videos. And then the other thing I want to get into is to show you the testing that I've done on the batteries. And, there's some surprises there in terms of how much power you're really going to get when you have that battery. And that'll make a difference when you go to, say, set up a new plane and you're trying to decide what size battery you need and how long of flights you want to have and things such as that. It's important stuff. So those 2 videos are coming. In the meantime, if you haven't done so already, subscribe, and there's the next video along the way. I'm RC Jim signing off. You have a great day and enjoy your flying.